Hey guys, this lesson is a continuation of our factoring. This is called advanced factoring, which I know is kind of synonymous with hard or difficult. It's not necessarily more difficult, but you will notice in a minute that our factoring flowchart grew. There's some other types of factoring that we have to discuss. So I enjoy factoring. I know not everyone does. Let's do a quick review of our typical types of factoring that we saw back in the quadratics chapter and before that. So we could have a general trinomial, which is those reverse foiling questions. So you start by looking at your trinomial and it's a little bit of guessing and checking, but you think about, okay, what times what will give me x squared in the first positions, and that has to be x and x. And then you think about all of your options for multiplying together to give you negative 12, and there are a lot. So 12 and 1, 3 and 4, 6 and 2, and you kind of play around with the numbers a little bit, knowing that one of your signs has to be positive and negative to produce a negative 12. And then eventually we settle on negative 6 and positive 2. And of course, we always check our arches, very important. This arch is a positive 2x. This arch is a negative 6x. And if we were to add those arches together, we do get negative 4x in the middle. So that's how we know we're right. It is a bit of a math puzzle, but you know, some people really enjoy these and some people just can't wait for them to go away. And I got bad news, it doesn't go away. Until you're done with math, at least. All right, difference of two squares, my favorite pattern. We call this the good twin, evil twin pattern. If you have a subtraction problem of two things that are perfect squares or things that can be square rooted, you perform that pattern. So the square root of 4x squared, or the twin factors, would be a 2x and a 2x. Similarly, you can square root the 9, and we get a 3 and a 3. And then the way the pattern works is you make one positive and one negative, and that's why we don't have anything in the middle for the arches. The arches end up canceling out 6 and negative 6. That's why there's no number in the middle. And then the most dreaded type of factoring for some reason, the one we always forget, even though it's at the very top of the flowchart, guys, are the common factor. So is there something, variable or number or both, that can be taken out of each term in the polynomial? And the answer is yes. They have a common factor of 2 and an x. So if you factor a 2x out of that problem, think of it like dividing by 2x. Think of what's left inside here. If you divided out a 2x, you still have an x and then plus 5. So sometimes we call that like the undistributing technique. That's a very not fancy way of saying to factor out. All right, so that's I don't want to call it basic factoring, but that's the kind of factoring we already knew. So here's our friend, the factoring flowchart. Once again, it's back. It's bigger. So we used to just have 2 terms and 3 terms, but now we have 4 terms that we're going to see today. That's exciting. Also, you'll notice in the 2 terms, you have 2 new friends. You have something called the sum of cubes and the difference of cubes. So on your factoring flowchart, if you have this printed for you, you'll see a box of perfect squares and perfect cubes. That's the same list that's on that weird chart that we gave you last semester. So all of these reference items can be found in your Google Classroom, I'm guessing. Otherwise, you can just email me and I can send you another copy of it. So trinomial factoring is the same as it always is. And then this new guy called factor by grouping, we'll talk about that. We still need to worry about factoring out common terms, though. That does not change. All right, here we go, down the flow chart. Step 1, factor out any common terms.
Good morning, Harlem High School.
Okay, so top of the flow chart, there's no common factor in this question. There's no variable, there's no number they can both be divided by that would make any difference. So now we move down the flow chart and we look at whether we have one of those patterns. So clearly it's not a difference pattern, there is a plus sign in the middle. So we're going to use what's called the sum of cubes. And what I'm going to do, and you should do this as well, is I'm going to write out the actual pattern that we're going to be factoring into on my paper for every question. So they have the a cubed plus b cubed part. That's what this is. It's going to end up factoring into something that looks like this. A plus b times a squared minus ab plus b squared. So that's the factoring pattern that it needs to look like. This one looks really crazy and complicated, but 2 things I'll tell you. Number 1, you don't have to memorize it for me, that I'm just going to give it to you. Number 2, it's actually one of the easiest patterns to use because once you've identified it and put numbers where they belong, you're done. This is not one of those trick questions where like we do one step and then, ooh, looks like there's another step to do. None of that happens for cubic patterns. And the only trick is that you got to tell me who a and b are. So this number right here, this is a cubed. And then this number right here, I'm going to use a different color though. This number right here is b cubed. So who is A and who is B? Well, think backwards, guys. If A cubed is x cubed, that means A is just x. And then again, think backwards. If B cubed is 27, think backwards or cube root it, that means B is 3. And then here we go. We're just going to place numbers where they belong, right in the pattern. All right, I'm going to put down my signs because they're not going to change ink color. All right, here we go. A plus B would be x plus 3. A squared would be x squared. And then plus A times B, well, instead of saying x times 3, a normal human would call that 3x. So I'm going to call that 3x. And then B squared, instead of saying 3 squared, I'm going to say plus 9. Ta-da! That's it. Okay? That is the factoring pattern for the sum of two cubes. Kind of crazy, I know. For some reason, the most difficult part for kids is figuring out who A and B are. So just a quick little note to yourself. To find A, we just cube rooted this number. And to find B, we just cube rooted that number. So remember, you have a chart of numbers for cubic roots. You can also use your calculator in the math menu. In the math menu, there's a cube root feature down there. All right, number 2. So back to the top of the flowchart. Look for any common factors. We don't have any common factors. So I move down the flowchart and I say, do I have 2 terms, 3 terms, or 4 terms? Clearly there's a 2 terms here. Also clearly it's a difference question, right? So if I notice on my flowchart, there's the difference of squares and there's the difference of cubes. So I have to just kind of stop and look at the question more closely. Are these squared numbers or are these cubed numbers? And the variable is usually the key. X to the 4th is a cousin of x squared, right? Is x squared squared. So this is the difference of squares, which is the pattern that we have been using for a while now. The pattern, I'm going to have to write it down here. It goes like this. A plus B times A minus B, the good twin, evil twin pattern. So the way this pattern works out is you square root each pattern, or sorry, each term, and that's what you place in for A and B. Same pattern from a month ago, okay? So the square root of 25x to the 4th is 5x squared. And then the square root of 36 is 6. And then we know the signs work out as 1 plus and 1 minus. And that's it for this question. Now, a word of caution. The difference of squares pattern is not lucky enough to be like, oh, we use it and then we're done. There will be questions possibly coming up where you use the difference of squares pattern and then you have to factor again. So that's the one major plus to the cubic pattern. That will never happen. And that's the only pattern, the cubic patterns, where you never have to factor again. Those are the most challenging questions, the ones that have a sneaky, like, third layer of factoring at the end. We'll see one of those, I think, coming up. Okay, number 3. We have clearly a difference. Oh, I should have started at the top. No common factor. We clearly have a difference question, but this time I can tell from the variable that this is the difference of cubes. So the pattern that we're going to be factoring this into, and I'm reading this right off the flowchart, it goes A minus B times A squared plus AB plus B squared. So again, I just kind of have to figure out who A and B are. So this guy right here, this is A cubed. And this guy right here, just the 1, not the negative sign, is B cubed. The signs are already built into the pattern. Don't touch the signs. So now I got to kind of figure out who A and B are. So same as that previous cubic question, I'm going to cube root that term, and I'm going to figure out that A is 3x. Don't lose your variable there. And then here I'm going to cube root, oops, I wrote over my 1. There's a 1 there. Okay. I'm going to cube root the 1, not the negative, just the 1. And I'm going to find out that B is also a 1. I'll put the numbers in place now, and then we're going to be done. All right, let me just shore up my ink a little bit. Negative, plus, plus. All right, here we go. So A minus B would be 3x minus 1. And this is where the problem might happen. A squared. So think of it as A times A. So it's not 3x squared, right? It's 9x squared. And then if I multiplied A times B, that would just become 1 times 3x. I'm just going to write it as 3x. And then B squared would be 1 squared, better known as 1. So I really like the cubic pattern, especially if my teacher's not going to make me memorize it. If you accidentally memorize it, that's okay. It'll be good for your SAT test, but I won't make you memorize it for the Algebra 2 course. Oh my gosh. All right, number 4. Start at the top of the flowchart. Are there any common factors that could be taken out of all 4 of these terms? And the answer is no. Usually that answer is no for a 4 term. So speaking of that, it is 4 terms long, and we're going to do what's called grouping. So I'm going to write a little note here of what technique we're using. So the way grouping works is you group the first 2 together, and they become their own little problem. And you do something similar for the last 2. And you look at them as their own factoring question, which means you start back over at the top of the flowchart and you say, are there any common factors? There are. If you look at just the first 2 terms, there's a common factor of x squared. So I'm going to factor out the x squared from that first group, and then look at what's left over once you take out an x squared. If you take out an x squared from here and here, you still have an x minus 2. Okay, now we're going to do something similar. In the next group, we're going to take out the common factor. It happens to be a 5. I need a sign with it, and I just said 5, so I'm assuming I meant positive 5. So what's left here and here when you take out a 5? Well, we still have, déjà vu, x minus 2. This is what's supposed to happen in grouping. Your groups, once you factor out from each group, should have the same little ending piece. So this factor and this factor should be exactly the same thing. That's how you know you're on the right track. So now what we're going to do is we're going to look at this problem like a giant factoring problem, where it's this term plus this term. Do you see that they have a common x minus 2 out in front, or in each term? So what we're going to do is we're going to take that common x minus 2 and factor it out in front of the problem. This is where it gets weird, okay? So I brought out the x minus 2, and think of this as being removed from the problem. So like you're gone, and you're gone. And what do you still have? Well, you still have an x squared, and then a plus 5. That was weird, right? That's how you factor by grouping. Now, I should have warned myself to keep looking for further factoring. Remember, only the cubic patterns are the ones that, like, you do them and you're done. So once in a while, these questions will have another layer of factoring at the end, but not this particular question. Holy cow, guys, that was fun. All right, let's see another example. Oh, no common factor here. So moving down the flowchart, we have a 4 term again, so we have another factor by grouping. So I look at my first group, and I ask myself, what could be a common factor that I could take out of that first group, the 2x to the third plus 3x squared? The only common factor they have is an x squared. So if I take out the x squared, I still have a 2x plus 3. Now careful on the last group. There's not really anything to take out other than the fact that there's negatives, which is kind of weird, and I need this first term to be a positive 2x. So I will have to factor out a negative 1. And when you factor out a negative 1, look what happens to the rest of the factor. Taking out a negative 1 from here and here gives you a positive 2x and then a positive 3. Remember, my warning from the last question was this factor has to match this factor, and if they don't match exactly, we won't be able to continue. Because our next step is to say, okay, out of this whole problem here, there's a common factor of 2x plus 3. Let's take that out in front. And then, once those are gone, I still have, do you see it? I still have an x squared and a minus 1. And this is the moment I've been warning you about this whole time. We're not done. Because this guy right here, x squared minus 1, is going to factor more. Do you notice that he's the difference of 2 squares? So the 2x plus 3 doesn't factor any further. But that x squared minus 1 is going to factor using that good twin, evil twin pattern, that x plus 1 times that x minus 1. These are a real hoot, let me tell you. And that's probably the most frequently missed question, like in math of all time, is the kid who halfway factors a question and then doesn't see that sneaky level of factoring at the end. Ugh, mean math teachers, right? Okay, number 6, back to the top of the flowchart. Are there any common factors? The answer this time is yes. So look, we have a common factor of x. So I'm going to take the x out of the problem. And when the x comes out in front, now we have an x squared, and then plus 3x, and then minus 10. Well, what I just wrote down in black ink looks like a very familiar normal trinomial that we used to have back in the day, right? And that's exactly what it is. So I'm going to go and continue my factoring process on the one that I wrote in black ink. So x squared would be x and x. I'm looking for numbers that multiply to negative 10, and then I'm kind of keeping my eye on the prize. I want my arches to add up to positive 3. So what if I did positive 5 and negative 2? Would that work? I should check the arches. 5, negative 2, yep, that's 3. And that is the final answer. So that was another case of, okay, I'm going to do one step on factoring, and I'm not done because I have another step that shows up after it. These can get real tricky, I know. We do have a few more questions here. Let's see here. I might skip around a little bit. I don't want this lesson to be forever long. Oh, let's do 7 and 8, and then we'll call it a day. All right. So 7, top of the flowchart, are there any common factors? And the answer is no, there's no common factors. So I move down my flowchart, it's 2 terms, right? So it's one of my patterns. I can see it's a difference problem. And if I look at the variable and the numbers, I can tell that these are squared numbers. So this is the difference of squares. So the pattern that we're using for the difference of squares is that a plus b and a minus b. So I just got to figure out who a and b are, and then we're good. Hopefully. We're not good. All right, so if I square root this first term, the twin factors of the square root of 16x to the fourth would be a 4x squared. That's not good. We'll talk about that. And then the square root of 625 is 25, which you can either use your calculator or your chart for that. Or maybe you just know it. I don't know. And then the signs are 1 plus and 1 minus. And it would be awesome if we were done. And then your teacher's going to get a sneaky look on her face and go, we're not done. All right, so this guy right here, he factors more. Do you notice that it is another difference of 2 squares pattern? So that first one is not going to factor. We cannot factor the sum of squares without using imaginary numbers, which we aren't going to do in Algebra 2. But this guy right here can totally factor again. Using that same pattern again, you can square root each of them, and it's the difference of 2 squares, right? So that would be like 2x plus 5 and 2x minus 5. How horribly evil! So this is what we mean by advanced factoring. There's more types of factoring. There's more layers to your factoring. It's just a good time. All right, number 8, back to the top of the flow chart. Are there any common factors? And the answer is yes, there are common factors. So we've got a common 7x. And when I take out 7x, I still am going to have, let's see, an x squared minus 100. And you know it can't be that easy, guys. There's got to be more. And there is. This one right here. This is the difference of 2 squares again. So leaving the 7x in front, don't lose that part. The x squared minus 100 will factor into good twin, evil twin, right? So x plus 10 and x minus 10. And that, my friends, is the final answer to that question. All right, well, does it take me as long as I thought? Let me peek ahead real quick. So 9, I'm just going to write some notes here, guys, and I'm going to finish the notes off camera, so if you need to go look at the PDF, the slides, you can see the worked out answer. This one would be the difference, obviously, of, and I can tell from the variable, it's cubes. And then a 4-termer here. We might need to do that one. This one's going to be grouping. You know what? I just love factoring so much, I can't end this lesson yet. I can't. All right, let's do this anyways. All right, the difference of cubes. There's no common factor. I'm going to move down. The difference of cubes pattern is a minus b. Oops, that's ugly. And then a squared plus ab plus b squared. So copied right off the flowchart. If only I could figure out what a and b were. So the cube root of 64x to the third, that's going to be your a value. And careful, 64 is a square and a cube, so make sure you're doing the right thing. It is a 4x when you cube root the 64. And then not the negative, just the 27 part. If you cube root the 27, you get a 3. The signs are all built in. So here we go, filling into the cubic pattern. I'm going to put my signs down though. All right, here we go. A minus B would be 4x minus 3. Be careful on this next part. Remember, a squared is like a times a. So 4x times 4x would be 16x squared. And then this next part, we got to multiply them together, right? 4x times 3, I'm going to call that a 12x because you do want to simplify that. And then 3 squared, better known as 9. Love the cubic pattern because I know I'm done. None of that sneaky secondary factoring is going to show up here, guys. You use the cubic pattern, you walk away. All right, and then grouping. You'll see why I wanted to do this one in a moment. My first group, I do see a common factor of x squared, so let's take that out. And if I took out the common factor of x squared, I still would have an x plus 5. And then this is where it gets weird. This next group, there's like nothing to factor out. Like there is no common factor besides a 1. And normally on any other day I would have said, forget the 1. The 1 doesn't do anything. This is the exception. I have to factor something out. So I am going to factor out a 1, a positive 1. Because that gives me something to keep in place for distribution. And then we still have an x plus 5, which matches the other factor, which is the important part of grouping, right? These have to match. So now, when I take a peek at that whole problem, I see that x plus 5 that I'm going to take out of the problem out in front. So envision them being gone. And then what do you still have? I still have an x squared and a plus 1. Now don't get excited. I know you're thinking, oh, that factors again. It's this difference of squares. Think about what you just said. The difference of squares. This is not a difference sign. That's a plus sign, right? So there's no sum of squares that we're going to be factoring in Algebra 2. So we actually stop here on that question. Wow, that was a good time. Okay, so advanced factoring, super fun. You want to have that flow chart out next to you. It's really important that as you work through them, you're acknowledging what kind of factoring you're doing. So even on my practice work, I might write down like grouping, sum of cubes. Write out the patterns. As you fill in the patterns, it'll make more sense later when you go to look back at them. All right, good luck, everybody. This is tricky, so make sure you practice a lot of these, okay?